Hello, welcome to my presentation on exploring ChatGPT, a deep dive into conversational AI. In this talk, I will cover the technical foundations of ChatGPT and its applications, limitations, ethical considerations, and the future of conversational AI. The presentation will outline key research areas and the practical applications of ChatGPT in industry. And in introduction to ChatGPT, foundations and technical background. ChatGPT is built on the GPT architecture, which uses transformation-based neural networks with self-attention mechanisms. This architecture enables ChatGPT to handle long-term dependencies in language, a critical factor in maintaining coherence in conversations. The model's training process involves extensive data sets, allow it to capture a broad range of language patterns from casual to formal context by leveraging billions of tokens. ChatGPT develops a deep contextual understanding which enhances its ability to generate relevant and accurate responses in varied conversational settings. Advance, Advancements in transform architecture for NLP. The transform architecture underpins ChatGPT's ability to manage complex linguistic tasks. A critical component here is the self-attention mechanism, which calculates the relationship between all words in an input sequence. Multi-head attention allows ChatGPT to consider multiple contexts aspects simultaneously, enhancing comprehension. The use of positional encoding addresses the sequences information which is inherently absent in transformers. This architecture has proven more effective than RNNs in handling to long-range dependencies, making it suitable for conversational models. Reinforcement learning with human feedback. Reinforcement learning with human feedback (RLHF) optimizes ChatGPT's responses by incorporating human evaluators in the training loop. Evaluators score model outputs, which guide the reward function adjustment. RLHF is vital for aligning responses with human expectations, reducing model bias and improving response quality. Although beneficial, RLHF requires human labor, limiting scalability and creating consistency challenges across diverse languages and cultural contexts. Data set diversity and influence on model behavior. ChatGPT's training data is vast and diverse, covering various domains. This diversity helps the model generalize across topics but also introduces biases from dominant perspective tokenization. Specifically, byte pair encoding (BPE) improves efficiency by breaking down word into sub-word units, essential for handling rare and compound words. Despite these advantages, the model is still prone to bias, especially when data predominantly represent certain viewpoints. Ethical filtering and regular updates are necessary to address these biases. Applications of ChatGPT in industry. ChatGPT is widely applied in customer support, automating response to improve response time and user experience. Its language adaptability makes it ideal for content creation, with assist in drafting, marketing, copy, and technical documentation. While used in routine tasks, ChatGPT faces limitations in high stakes applications like healthcare or legal settings, where factual accuracy is crucial. Research is ongoing to develop verification mechanisms to extend its use in these areas. Limitations and challenges in ChatGPT's framework. ChatGPT struggles to maintain coherence in extended conversations, especially with complex topic shifts. Its transforms basic architecture has a token limit, impacting context retention. Moreover, open domain models like ChatGPT are vulnerable to generating bias or inappropriate response despite context filtering efforts. Another limitation is the computational cost. Training and deploying transformers is resource intensive, impacting scalability and raising environmental concerns. Ethical implications and responsible AI deployment. Ethical challenges in ChatGPT involve managing biases, ensuring fairness, and maintaining transparency. OpenAI employs techniques like data filtering and reinforcement learning to mitigate bias, but challenges persist. Transparency is limited due to the model's black box nature, making it hard for users to interpret decision making process. Privacy concerns are also significant, particularly in regulated industries, necessitating robust data protection measures. Integration of large language models. Large language models LLM like ChatGPT are embedded in various workflows including customer services and virtual assistants. Their primary advantage is handling diverse linguistic tasks with minimal human intervention. However, LLM can underperform in specific high precision tasks like medical diagnostics, specified models might be more effective. Fine tuning for industry specific applications is common but requires additional training and may introduce overfitting issues. Data privacy and security challenges. ChatGPT's deployment raises privacy concerns due to its interaction with potentially sensitive user information. Privacy enhancing techniques like differential privacy and data anonymization are essential to mitigate these risks, though they can impact model performance. Compliance with data protection regulations such as GDP or HIPAA is crucial for industries handling personal data. Privacy preserving AI research, such as encrypted computation, is advancing to address these challenges. Comparison with competing conversational models. ChatGPT often competes with other large conversational models like Google's LAMDA and Meta's LLAMA. While ChatGPT excels in general conversational tasks, models like Lambda are specifically optimized for nuanced question answering. Performance benchmarks reveal strengths and weaknesses in different applications, indicating that task specific optimizations may be necessary. Comparative studies show that ChatGPT is versatile but may require fine tuning for domain specific applications. Optimizing ChatGPT for domain specific applications. Fine tuning adopts ChatGPT for specific industries like legal and healthcare. By training on domain specific text, the model gains relevance but risks overfitting in healthcare. For instance, customized models provide patient support by handling common queries. However, accuracy challenges and data scarcity in specialized fields complicate domain adoption. Zero shot and few shot learning techniques are explored to improve adaptability with large data sets. ChatGPT's contribution to natural language understanding (NLU). ChatGPT's transformer architecture enhances natural language understanding through attention mechanisms that enable context retention. This capability allows it to interpret complex sentence structures and detect user intent with high accuracy. Despite these advances, ambiguous phrasing can still lead to misinterpretation, and improvements are needed in areas like mission comprehension and information retrieval. ChatGPT's contributions demonstrate the potential of transformer models in NLU tasks. The technical challenges in scaling language models. Scaling ChatGPT involves extensive computational resources, making it costly to train and maintain. Distributed training and model parallelism are common techniques for handling large data sets, but the data and complexity, the environment impact of training large models is significant, with research focusing on efficiency improvements. Techniques like space transformers and low rank matrix factorization are explosive to reduce computational demand without compromising performance. Enhancing model interpretability and explainability. Interpretability is crucial in high stakes applications like healthcare, where understanding AI decisions is essential. ChatGPT's decision making process are complex, making explainability difficult. Techniques such as attention visualization, saliency maps, and LIME help clarify model outputs. However, these methods often reduce model performance, and research is ongoing in developing self explaining models that provide interpretability without trade offs. Multilingual and cross cultural context. ChatGPT can process multiple languages, but it performs inconsistent across languages, especially in low resource languages. Cultural nuance and idiomatic expressions remain challenging. Cross linguistic embeddings and language agnostic training are areas of active research to address these issues. Transfer learning across language and cultural fine tuning are explored to improve ChatGPT's relevance in multilingual and culturally diverse settings. Ethical and social impact on ChatGPT. Conversational AI has a substantial social impact, particularly in reducing human interaction in customer service. Ethical challenges include dependency on AI, potential job displacement, and dehumanization in service sectors. Bias is another critical issue, as ChatGPT can unintentionally reinforce stereotypes. Long term ethical research focuses on creating responsible frameworks for deploying AI in ways that align with societable values. Future innovations in conversational AI. Future research on ChatGPT aims to improve contextual memory and responsible personalization memory. Augmented architectures could enable longer conversation coherence, while privacy preserving methods ensure data confidentiality in personalized response. The goal is to advance general AI systems capable of flexible interaction across various topics. Meta learning and adaptive transformers are explored to achieve more robust and versatile conversational agents. Summary and key insights. In summary, ChatGPT has advanced conversational AI, but limitations in scalability, interpretability, and ethical compliance remain. Key research areas include model transparency, ethical deployment, and cultural adaptability. Future work focuses on making models more efficient, interpretable, and responsible, aiming to broaden the impact of AI across sectors while addressing its ethical challenges. So, finally, references and further reading research papers and articles. It provides the direct links to foundational and current research papers, including. For further study, I recommend foundational papers such as Attention is All You Need by Vaswani et al. And Aligning Language Models to Follow Instruction with Human Feedback. These sources, along with recent research on ethical AI and domain specific applications, provide a deeper understanding of the topics covered in this presentation.